Hello guys, welcome back to my YouTube channel. I am Karina from the Department of CSE Cybersecurity. Our today's subject is software engineering and our topic is waterfall model. To begin with, what is a waterfall model? It is a foundational software development methodology characterized by its structured linear approach. It operates on the principle that progress flows steadily downward like a waterfall through clearly defined phases. Each phase must be fully completed and approved before the next phase begins. It is a highly disciplined process. This sequential nature ensures that no phase overlaps or repeats, emphasizing meticulous planning and documentation. The model's strength lies in its simplicity and clarity, making it suitable for projects where requirements are well understood and unlikely to change. It emphasizes on detailed documentation, provides a strong foundation for long-term maintenance and troubleshooting. However, the waterfall model is not without limitations. Its rigidity makes it challenging to adapt to the changes in the requirements. Once the process has begun, and it often delays testing and user feedback until the later stages, increasing the risk of defects or misaligned expectations. Despite these drawbacks, the waterfall model remains widely used in industries like construction, manufacturing, and government projects, where a structured approach and strict compliance are essential. Its legacy also serves as the basis for many modern development methodologies, including agile and iterative models. This is the flowchart of a waterfall model. There are 6 phases. The first phase is requirement gathering and analysis. Next is the system design. Third, implementation. Fourth one is integration and testing. Fifth one, it is development. And sixth one is the maintenance. So let us discuss about the first phase, which is the requirement analysis. Its main objective is to gather and document all functional and non-functional requirements of the system. The key activities are it conducts meetings with the stakeholders to understand their needs. It creates a detailed requirement specifications including user cases and use cases. A formal requirement specification document is formed. The next is the system design. It creates a blueprint for the software system based on the gathered requirements. Here, the key activities are a high-level design, which focuses on architecture, data flow, and system components. A low-level design, which focuses on detailed modules, algorithms, data designs, and interfaces. Its main aim is to design documents, including diagrams like ER diagrams, UML diagrams, and system architecture. The third phase is the coding, which is the implementation phase. It transforms the design into an actual working code. The developers write and compile the code for each module based on the design specifications. It performs unit testing to ensure individual components work as intended. A fully developed and individually tested software modules. The next phase is the integration and the testing. It combines all the modules into a functioning system and ensure it meets the specified requirements. The key activities are integration testing. It validates that different modules work together correctly. System testing. It verifies whether the overall system functionality, performance, and security. Next is a user acceptance testing, which tests the system with real users to ensure it meets their expectations. Here, a thoroughly tested and defect-free system is delivered. Next is the deployment stage. Here, it delivers the fully tested system to the client or production environment for use. It installs the software in the production environment, provide user training and manuals, roll out the software to the end users. Operational software accessible to the end use is delivered. Next is the maintenance phase. It ensures that the system remains functional, secure, and up to date, which can also lead to post-deployment phase. The key activities are it fixes the bugs or defects reported by the users, implement updates or enhancements based on the user feedback, perform periodic checks to maintain compatibility with evolving environments, At the final, the updated and well-maintained system is being delivered. What are the advantages of a waterfall model? As it is a structured and the linear approach, it is ideal for the project with clear and stable requirements. It is a phase-wise progression, ensures each stage, that is requirement, design, implementation, testing, deployment and maintenance, is completed before moving to the next, offering clarity and predictability. The model emphasizes comprehensive documentation, providing a reliable reference for future maintenance and upgrades. Its simplicity and defined milestones make it easy to manage and track the progress, making it particularly suitable for projects with fixed timelines and budgets. Next is the disadvantages of the waterfall model. Here, the requirements are subject to change. So, if it is rigid, sequential nature makes it difficult and costly to accommodate modifications once a phase is completed. Testing is deferred to the later stages, increasing the risk of identifying the critical issues or misaligned expectations only after the significant work has been done. Additionally, customers and stakeholders have limited involvement after the initial requirements phase, often leading to a final product that may not fully meet their needs. The model's reliance on detailed upfront planning and documentation can also make it less efficient for complex or evolving projects. And mainly, it lacks with the flexibility and iterative feedback loops offering by the modern methodologies like agile process modeling. So let us look into a real life example, which is a NASA's Mars rover project. The mission involved sending a rover to the Mars to gather data and explore the surface. The project followed the structured, sequential approach similar to the waterfall model. The first phase is the requirement analysis. Here, the NASA defines the rover's objective, size, weight, and the instruments through detailed planning with stakeholders. Next is the system design. Engineers created detailed design for the rover's hardware, software, and power system, ensuring it could withstand Martian conditions. Next is the implementation. The rover was constructed based on the finalized design, followed by the testing on the Earth. The next is the integration and the testing. All the systems were integrated and thoroughly tested to ensure the rover would work correctly on Mars. Deployment. Once it is tested, the rover was launched to the Mars, where it landed and began its mission. Maintenance. After the deployment, NASA monitored and maintained the rover, fixing issues remotely. So therefore, the waterfall model was ideal for this project because of its fixed requirements and need for the detailed planning, making it crucial for a complex, mission-critical project with little room for changes. Conclusion. So the waterfall model remains a foundational concept in software engineering. It provides a structural approach that can lead to a successful project outcomes. Understanding its strengths and limitations is essential for effective project management. This presentation summarizes the waterfall model, highlighting its phases, advantages, disadvantages, and applications in the software development lifecycle. Thank you guys. Stay tuned for more such videos. Please do like, share, and subscribe.